We are going to continue with our mathematics library. In this video, we're going to see how we can generate and manipulate vectors. Now, I've decided to revert back to Visual Studio Code Editor. In the last video, when we started looking at the mathematics library, I used Notepad, and whenever I made the video, it was all kind of white, a bit washed out. So this is a little bit neater, a little bit more professional looking, and it's a bit easier on the eye. Now, as I've mentioned in other videos, I'm not going to go through the mathematical details of what vectors are and how we manipulate them. I'm not going to go through the details of how we actually write the subroutines to manipulate the vectors. If you're interested, you can find that information within the YouTube channel, or if you're wanting it all in glorious detail, all ordered properly, then you can get that on Design a CPU 3 course. We want to just be able to quickly go in and write the code and manipulate vectors, and that's the point of this video series. So let's start off by looking at vector addition. Now, before we can do anything, we have to be able to represent vectors, and we're going to represent vectors using the idea of an array. So in terms of our computer science or computer literature, an array is simply a list of numbers separated by commas. So for example, if we wanted to represent a vector 1, 2, 3, 4, we just generate an array. So you can see here I've got DC array underscore 1, and it's 1, 2, 3, 4. So each of the components of the vectors is separated by a comma, and it's represented within this array. So that's something new that you won't have seen before. So what we're going to do here is we're going to add two vectors together. So we have array underscore 1, array underscore 2. Now, in order to add the vectors together, you add them in terms of their components. So for example, it would be 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 4 is 7, 4 plus 5 is 9. So it's going to be 3, 5, 7 and 9. And there you see it down below. I've got that actual example written out. So we're going to push array underscore 1 and array underscore 2 into the subroutine. Now remember, whenever we're pushing these, what we're actually pushing in this instance here is the address of the first number. So we're actually pushing, in this instance, array underscore 1, we're pushing 0 cross 8500. Okay, so not the number 1, we're just pushing the 0 cross 8500, which is the address. And we're pushing the address of this one here as well. And within the actual subroutine, the subroutine works out we know this is the address, so it goes and actually gets the actual value within the address, and it works through it using that route. So in effect, in this case, we're pushing by reference as opposed to pushing the values into the subroutine by value. Now, one other thing to note here is that whenever we did the simple mathematics library, we were only ever returning one result. So it meant that what we could do is we could just push that result onto the stack, and then when we go back to the calling function, we could just pop the value off and put it in a memory location. But in this instance here, we're going to, whenever we add these two together, in this instance, we're going to get 4 values coming out. Now, if the vectors were 10 or 15 or 20 components long, we would get all of those values coming out as a result. So we didn't want to get into the subroutine and then push all those values on and then come out and then pop them all back off again. So it was just a bit awkward. We want to try and keep things as simple as possible. So a nice neat way of doing that is to tell it where the subroutine where to store the results. So we're going to store the results in array underscore 3, and you can see here we've got DS for defined storage, and it's array underscore 3, and it's going to be 4 memory locations. So we set aside 4 memory locations for the result. And also, one other thing we have to do is that whenever we're manipulating vectors, we have to be sometimes have to be careful about the lengths of vectors, because sometimes they may values on the length may change, the number of components may change depending on the manipulation. We'll see this more when we look actually at matrices. So we have to tell it what is the actual length of the vector, how many components does it have. That's another piece of information that has to go in. So we've got these 4 pieces of information. They have to be put in this order, and note that the length is, we're actually passing the length in by the value, as opposed to the array, which we're pushing it in by reference. So we're pushing the array address in, but we're pushing the actual value of the length in. Okay, so that's something we have to be careful about, and that's the reason for writing it down like this, so we always get it right. So whenever we've done that, it jumps to the subroutine, it works through the subroutine, and it pops out the values, and it'll pop out the answers actually in the correct memory location. Okay, so you can see where the memory location is going to be. The 0 cross 8500 is going to contain the number 1, and then 8501 will contain the number 2, and then it'll be 3, 4, 2, 3, 4, 5, and then it'll be a number 4, and then we've got 4 memory locations available for the answer. So that's how we work through the addition. Now we'll move on to look at the subtraction. Now the subtraction, we don't really need to talk through it very much, because it's exactly the same as the addition in terms of how we actually push the values in. Now the only difference here is within the subroutine, instead of adding the vectors together, we subtract them. Okay, and here's an example here, so I've just given that example. So that's pretty straightforward. Now again, we're going to go through, we'll pick one of these out and we will go through it within the machine. Okay, now we're going to go through the multiplication. So we've got multiplication by a scalar. So an example here, we've got the vector 3, 1, and we're going to multiply it by 2. So when we multiply that, we get 6, 2. So we just multiply the components together. So in order to do that, we're going to have to pass in the value of the scalar. In this case it's 2. We're going to have to pass in the array underscore 1, array underscore 2, and also the length of the array. We jump to the subroutine, and then it generates the correct answer, and it places it into the array underscore 2, which is array underscore 2, which is the where the answer is held. So again, that's quite straightforward. Now there's another, whenever we're actually multiplying 2 vectors together, there's 2 common ways of multiplying. Now one is called the dot product and one is called the cross product. So in the dot product, the result that comes back is a scalar value. That's why it's sometimes called the scalar product. So in this instance, we're going to push array underscore 1 in, we're going to push array underscore 2, we're going to push the length of the array, and we're going to push the position where we want the result to be stored. So we're going to store it in the position dot. So it goes through the subroutine and it will return the answer into this memory location dot. So that's quite straightforward. Now the final one here we're looking at is the cross product. So the cross product here, we only do the cross product by a 3 by 3 matrix. Now if we wanted to, we could generate the cross product of a 4 by 4 or a 5 by 5, but it would be long and involved, and not many people would bother using them. Generally we're only interested in the cross product of a 3 by 3 matrix. And in fact, but that's all we're going to do here anyway. Okay, so in this instance we don't need to put the length in because we know it's a cross product of a 3 by 3 matrix. So all we need to do is push in the array 1, push in array 2, and then we push the position where we want the result to go to, and then we jump to the subroutine, and then it will just put the result into those memory locations. And I've chosen these values here as an example, and I haven't actually finished off here with the result of this, so you can always work out what the cross product of these two are, and then you can run it on the machine and check and see whether it gets the correct result. So let's go ahead and we'll pick one of these and then we'll run through it within the machine just so you can see how it runs and where the results are stored. I decided to go through the addition one. Okay, so this is the program here, and we're going to add these two vectors together. So we're going to get the final vector, which is going to be 3, 5, 7 and 9. So let me load this into the machine and we'll see it running. I have loaded the code into the machine, so let's run it up, and I'll just run it at full speed for us. Now I have a copy of the code here which we can refer to. Now we have it here. So it's loading up all of the values. So in effect it's got to load in all of these values into memory. And now it's jumping through and going through the actual addition. So it'll only take a few seconds for that to finish off. That's it finished now. So let's go in and we'll have a look at the results within memory. So I'll stop that. Now everything's up around about 8500, so that's 8500 here. So according to our code, and it's maybe a bit small, but I think you can possibly see it. So we've got the value of our array 1, which is going to be 1, 2, 3, 4, and then we're going to have the array 2, which is 2, 3, 4, 5, and then the length of the array is, each of the arrays is 4, and then the summation is going to come in on the next value. So the summation is going to be 3, 5, 7 and 9. Okay, so that's how our simple vector addition is going to work. And whenever we look through and generate the subtraction or the dot product or the cross product, they'll work in the very same manner, and we will be able to pull the results out from memory. So that's all for our vectors. In the next video we will look at how we can manipulate matrices. So thank you for listening. I'll get you on the next video. Goodbye.